So welcome back to part 3. This is about the world's most advanced over-engineered Christmas tree bauble. So next up is the spinner. This is one of my favourite ones. I created this yesterday. So let's go over to Thonny again. Just going to run this code. We can have a look what this looks like. So what it does is it spins around, and each time it goes round it gets faster and faster and faster. Before you know it, it's going crazy. It's quite a nice effect. It's also cycling through colours as it does this. So it starts out as red. You can see it's going sort of an orangey colour now, yellow, and then from yellow to green, and then from green to sort of blue. And then when it reaches a certain number, it'll start again. So it's just an interesting one, and it's basically addressing each RGB LED pixel apart from the first one, which is in the middle. So because these are arranged in a circular formation, if you address pixel 1, 2, 3, 4, 5, and 6, you'll get these effects happening. We've got some code that will basically just erase the previous LED value and make it look interesting. I think I've actually got a bit of a fade effect on this as well, so whatever the previous one's like halved in value. So let's have a look at the code on this. So here we go. So we've got the usual importing of things. I'm importing RGB as well, the usual 7 LEDs, the speed and the updates as we saw previously, and the brightness value. I set this to 1 this time. You can see there we've got the usual plasma stick LED strip setup and starting the strip. We're setting the offset similar to what we just did in the rainbow effect. And then the spin code is basically a loop with loops within it. So we're going to set our colour to be RG and B. So whatever we're passing into this, it's going to pack that into a little list there, dictionary even. And then we're going to then convert that RG and B into hue, saturation and value, so we can play with it a lot easier. Then we've got 2 loops. We've got one called K and one called I. So K is the kind of outer one, which is going to cycle through. What do I actually use that one for? I can't remember now. So we've got an outer one, we've got an inner one, which is I, and then I is the one that's actually addressing the number of the LED pixel. And we're changing the hue and the saturation over time there. And we're saying that the previous one, we're basically going to blank that out. So you can see that I've got 2 calls to set HSV. The first one just says if I is 1, so it's not 0, then we go to the previous one and just make that black. So it's just going to turn that one off. Otherwise, set the value. And then for J in range 1 to whatever the I currently is, and this is the fade effect, we'll basically just do a bit of math here. We'll set the previous pixel to be half the brightness of the previous one, the same color. And then we do that time sleep updates bits and pieces. And then I've got another piece of code down here, which is sort of the main loop. So I start out with the color red and then pass that into our converter to get the color. We then set the hue to be whatever that color was from there. So we're just converting RGB colors to a hue. And then I've just arbitrarily said for range 4 to 500 in steps of 10, increase the hue value by 0.01, so very slightly increase it, and then basically just go around a loop, do the spin function. So that's what we see on here. There's this nice spin effect. And as I'm looking at, you're looking at it through a camera that's got a certain number of frames per second, so after a while it sort of looks like it's switching between 2 of them. If you look at it in real life, it looks like it's spinning around crazily fast. It's really quite cool. Okay, so that is the spin one. So let's see what else we have. We have Cheerlights. So this is what we're talking about. Let's go over to our Cheerlights. So let's go to me for a second while I switch back over to Thonny. Here we go. Right, so let me just close that code and reopen it. So I'm going to stop that running as well. And I'm going to load up our Cheerlights code. Okay, so there's quite a lot going on with this, as you would expect. So we need to connect to Wi-Fi because we need to connect to the World Wide Web to a very specific URL, which is the URL for the Cheerlights API, so cheerlights.com. So to enable that, we need to grab what our current Wi-Fi SSID and password is. We need to use the network manager to help us sort of connect to our Wi-Fi nice and simply. And then we've got these things called asynchronous I/O and requests. These are to do with when you're connecting to the network and when you're requesting things from the network, from the World Wide Web, you need to use these 2 functions. We've got time plasma, plasma stick. We know what those are. And machine pin, this is because we want to actually enable the LED on the plasma stick itself. There's like a tiny little LED on board the Pico. It was on pin 25, it's now moved to a different area, and we can address that by just doing machine pin. And then we're importing the RGB library that we built earlier. Right, so here we go. This is the URL we need to connect to get the last color. So http api thingspeak.com/channels1417 field/2 last.json. Now this should really be 120. We need to be nice to free APIs. I'm hitting this every second just because I wanted a almost live update. So in a minute, if you want to get on Twitter and you want to tweet out #Cheerlights space and then a color, so put it in the chat what color you're going to change it to, and do that, and we should be able to see this change in a second. So number of LEDs is 7. The brightness on this one is a value between 0 and 31, which I find weird, but it is what it is. And then there's a status handler, which basically just tells us, this whole block of code basically just says, have we connected to Wi-Fi or not? And there's a little loop in here. I've stolen this from Hell's code from the Cheerlights example on the plasma stick. And essentially what this first loop does is it sets all the lights to white, waits for a very short amount of time, sets them to black, and they'll just basically flash like that until the Wi-Fi is connected. If the Wi-Fi fails, it'll go to spooky rainbows, which is pretty cool. So there's a whole thing there about spooky rainbows, and this is a very similar kind of thing that we've seen previously. So we'll have a look at what that looks like. If we do succeed, then we're connected and we can try the code which is further down here. So let's have a see, and we'll actually get the color that we want being displayed on all the pixels. So the Pico LED is the pin that's called LED, and then we set that pin to an out, and then we can use that just to display when we're grabbing the data, make that pin high so we can see that the LED comes on the Pico. So we're then setting up the LED strip. Remember, I've got the weird order in there of GRB instead of RGB, starting the LED strip, and then we've got this try except block just to see if we can connect to Wi-Fi or not. If it fails, we can do spooky rainbows. Otherwise, we can run this code. So this is how we can connect to Cheerlights, and we can set an RGB LED value from a hex value. So we're going to put the URL that we defined above, which is that ThingSpeak one, into this this request. We're going to then grab the data that's returned from that request into our J thing there. We're going to close as if it's like a file, we just close it down. We then say Pico LED value is true, and then sleep for a tiny little bit just to make it flash, and then we make it go off by setting the value to false. And then we then extract the hex value, which is field 2, into this variable that's called hex. We can then pass hex into our hex to RGB converter function and get an RGB value back, and then we can convert that RGB value into a HSV value so that we can play with it. And then we say for each of the LEDs in our LED strip, we want to set all of them to those red, green and blue values. So it looks like I've actually not done anything there with the hue saturation value, so we could probably remove that. I do print out what it is, and you can see that coming through. And then we sleep for whatever the update cycle is. So let me run this and let's see what happens. So it's grabbed the values. You can see there that we're currently getting a sort of pink colour. If I go over here, it's a nice sort of magenta pink colour. So if you now hit, and you can also see in the skull behind me as well, that's also synced up. So somebody's now done yellow. So we should see the skull change to yellow as well shortly. But we've seen that the bauble has picked up that colour and has now changed to yellow. That one seems to be a little bit behind. I'm not sure what's going on there. Oh, it's changed to cyan now as well. Somebody else has changed that. Awesome. Awesome. So Hans changed it to yellow. Somebody else has already changed it to a sort of a blue colour. That it looks a little bit lighter in the studio than it does here. And I've actually turned off the overhead lights. If I put them on, it sort of gets really washed out. But if I bring the lights down, you can see what it looks like there. So come on, some other people choose some other colours. Somebody's done green. Let's see if the green comes through. Yep, the green's come through. Fantastic. We can see that. This is so much fun. Now imagine if there's like entire buildings with Cheerlights enabled on all their lights externally. I've got some garden lights. I think I've got 8 lights in the garden. There's like 3 rows of 2, and then there's 2 sort of uplights either side. They're all RGB LEDs. They are going to be Cheerlights, so my garden will be Cheerlight enabled very shortly. And yeah, it's so much fun, so much fun. Not sure what's going on with the school though. That's decided to go to blue now. I think it's a little bit behind, that one. I think it must be a bit of a delay. I think it does it only 2 minutes or something like that, whereas this one's doing it every second currently. So much fun. I'll reduce this back down. We don't want to have this hit every single second. If everybody in the world did this, that ThinkSpeak API would basically just melt down, and it'd probably just back you off as like a denial service. So we're not gonna do that. Okay, so that's Cheerlights. Love this so much, and I think we'll have to have Han come on the channel and have a chat with him about this project. I think it's just so much fun, so we'll look at that for a future. Of course, the supporters. So this is a growing list, and I'm really pleased that it's a growing list because it just means that we've got more support for the channel. So you can see there we've got Schultz Maker, our Schultz Maker, we've got Frank, we've got Dana Hoff, we've got Grumpy Scrambler, we have David, we've got Matt Hungerford, we've got Flavia of Dev, Patrick. Our members, we have Shemi, we have Steve, we have Thomas, and YouTube members. This is a growing number of people, so we've got Cheerlights, woohoo, thanks Hans. We have Michael, we have Fraser, we've got Bill, we've got Jose, Jeff, Johan. I'm not very good with my Spanish or Mexican kind of names, so is it Jose and Johan? And we have John Paul Jolly, and we've got Tom as well. Fantastic. Thank you everybody for helping me with the channel by supporting it in these ways. And if you want to see your name on the credits here, just head over to kevsrobots.com/credits and you can get yourself over here as well. Okay.